if you think about it, in many games, in even real life situation, some players will move before the other in a game, right? For example, in many sports like chess or in market competition also, there's someone who's the first mover and some others the second, the third mover. And this sequence of movement could potentially give players some benefit. For example, the one who moves later could observe what the others have played up to that point to his move and then form more sophisticated or better decision, more informed decision. On the other hand, who moves first can have some benefit also because they actually narrow down the set of possibilities for the other, right? And they force the other to play it in certain way, right? And thereby influence them, those who move later. So we will analyze this situation now. In order to see the difference between this sequential game and the simultaneous game before we had, let's look at the same example, the battle of the sexes. However, now with some modification, the wife will move first. She chose where she wants to go first, and then the husband observes her choice and decide accordingly. The possible strategies of the wife stay the same as before. So she would decide either to ballot or boxing, right? However, the possible strategies of the husbands now expanded because for each of his wife's actions, he could choose one of the two actions. So his set of strategies now includes first is always goes to ballot. Now that means he would go to ballot. I don't know why it make that strange symbols all the time. So contingent or conditional. So this vertical bar is read conditional. Conditionally on his wife going to ballot. And he will also go to ballot when she goes to boxing. Okay. The second one, he will follow his wife, meaning he would go to ballot if she go to ballot, and he would go to boxing if she go to boxing. Contingent on his wife action. The next one is to do the opposite. That means he would go to boxing if she goes to ballot. And then he would go to ballot when she goes to boxing. That sounds a bit strange, but anyhow, it's included in the information. Sorry, the possible strategy set. And then the last one would be he always goes to boxing. In particular, he go to boxing when his wife go to ballet, and then he go to boxing when she goes to boxing. These are the 4 possible strategy of the husband. For the extended form, is actually pretty much the same as in the version of the simultaneous game before. However, if you notice, now we don't have the dotted circle around this anymore. That indicates that now the husband makes the decision separately from the wife. So not from the same information set, not at the same time anymore. To see why this decision tree is pretty much the same like before, let's think about the 4 strategy of the husband again. The first one is when he always go to ballet. So the wife move first, go to ballet, and then he go to ballet, and he end up here. Then even when she goes to boxing, he will still go to ballet, and then he end up here. So that is the first, the first one. Okay. The second one, he follows his wife. That means if she goes to ballet, then he also again go to ballet. So this the second. If she goes to boxing, he would go to boxing. So this is the second possible strategy for him into these 2 notes, right? And then the third one, do the opposite. So she goes to ballet, he goes to boxing. This is the third one. She goes to boxing, he goes to ballet. This is the third possible strategy. The last one, always go to boxing. So she goes to ballet, he goes to boxing. So 4. And she goes to boxing, he goes to boxing. Now, so each of this pair of combination now summarized 2 out of 4 possible strategy of the husband. One difference of this decision tree to the earlier one is that now the husband knows exactly either if he's here or he's here when it's his turn to decide. Before that, with the oval, the dotted circle around, it's indicated that he didn't know. And now he knows that. And he observed the moves of his wife up to these 2 decision nodes. Okay. Now we look at the normal form of the sequential battles of the sexes. And then we solve for Nash equilibrium by using the underlying procedure that we know before. And only after that we think about what to do where in the case that has many equilibria. So let's go. like I said, this is the extensive form. It's pretty much the same as before, just with the dotted circle. Yeah. So now we have the wife. Let's write here on the vertical one, and she has two strategies like before, either ballet or boxing, right? So this is her strategy. All right. The husband, however, has four possible strategies, right? The first one is he would always goes for ballet. So he go for ballet when the wife go for ballet. So this is what he plays, contingent on what she plays. That's how you read it. And then again he go for ballet when she go for boxing. This is the first one. The second one is he always follow her. So he would go for ballet when she go for ballet. And he would go for boxing when she go for boxing. Okay, this is the second one. The third one is always goes against her. That sounds a little bit strange. Yeah? So he go for boxing when she goes for ballet, and then he go for ballet when she goes for boxing. He just doesn't want to go with her. The last one, maybe a little bit, he always go for boxing, doesn't matter where she goes. So boxing, ballet, and then boxing, boxing. Yeah. Okay, that's all. Now we could pick the payoff to put into the matrix, right? So if she goes for ballet, then contingent on she goes for ballet, he goes for ballet. So that is she earns 2 and he earns 1, right? Where is it? It is she goes for ballet, he goes for ballet, and she goes for boxing, he goes for ballet. So this is the first possible strategy of the husband. The second one, okay, the second one, she plays ballet and contingent on her playing ballet, the husband follows her to ballet. So this is the same note here, right? So again, she would earn 2, he would earn 1, right? Where is it? So he always follow her. So again, she goes for ballet, he goes for ballet. She goes for boxing. He goes for boxing. This is the second possible strategy. Okay. The next one, she plays ballet, and contingent on her playing ballet, he plays boxing, because now he always wants to go opposite her. So that is 0, right? 0. So he always wants to have 0 payoff for both of them. That's the third one. Where is it? Good, I have a lot of cards. So she goes to ballet, he goes to boxing. She goes to boxing, he goes to ballet. That's the third possible strategy. And then the next thing is she plays ballet, he goes boxing always. So that is again 0 and 0, right? Now she plays boxing. Sorry, I missed something. So there must be somewhere over there, boxing always. So doesn't matter if she goes for boxing, he goes for boxing. And she goes for, she goes ballet up there, and now she goes boxing. He also goes for boxing. So this is the 4, right? Let's do the second strategy of the wife quickly. So boxing, and the first line, the color, boxing here, ballet, boxing, ballet, 0, 0, right? Boxing, and then always go with her, so boxing, the green one, and boxing. Now, so 1 and 2. All right. Boxing, ballet, ballet, boxing. Always goes the opposite. But now the wife moved boxing, so the pink line, where is that? Here, right? So it is again 0, 0. Because always goes opposite, meaning always earn 0 payoff, right? And the last one, boxing, ballet, ballet, boxing, boxing, always goes for boxing. And now the wife goes for boxing, so let's look at the purple line over here. 1, 2, right? The next thing we will do underlining procedure to find the Nash equilibrium. So underlining procedure, if the Y goes for ballet, then these two payoff should be higher than 0 over here. That means the husband should choose some strategy involving him playing ballet when the wife goes ballet. And that's 2 strategies. Always goes for ballet or goes with her. Doesn't matter where she goes. Okay. If she plays boxing, similar reasoning, should choose a strategy which indicates that he would go for boxing when she goes for boxing. Including the 2 cases, always go with her and always go boxing, right? And for her, if he always goes for ballet, then she wisely should choose ballet, right? Because she would or not think choosing boxing. If he always follow her and she knows that, then of course she would prefer going to ballet, her old preference, than boxing, which earn her less payoff, right? And then if he want to go against her will anyway, he doesn't want to end up being in the same activity with her, then doesn't matter what she chose. The payoff's the same, 0. So we underline both. Now, pay attention, this is a tie result, and you have to underline both. Okay, the next thing, the last thing is he always go boxing. Then, rationally, she should go boxing, because otherwise you are nothing, right? So now we have, from this procedure, 3 Nash equilibria. The first thing is the wife lay ballot, the husband play ballot, ballot, always ballot, ballot, boxing, right? The second one, which is here, again the wife play ballot, the husband play ballot, ballot, boxing, boxing, always follow her. The third, the final Nash equilibrium is here. So that is the wife plays boxing and the husband plays always boxing. Boxing, 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 ballot. Okay, that's how we think about it. The problem now is we have 3 Nash equilibria. How can we know which one's more likely to happen? So one point to notice here is that not all the Nash equilibria here rational. There may be some equilibria not rational at all. Let's take one example. The first equilibrium, this one. So the husband treats the wife that, okay, I will always go to ballot, even when you choose boxing. Is that reliable? It's actually an empty threat, because if the wife were to go to boxing, then he would earn 0 payoff going to ballot, rather than 1 payoff going to boxing, for example here and here, right? So this is not rational. Doesn't make sense to make that threat to the wife, and because of that, that would not be enough to deviate her from going to ballot. No? So that kind of thing we call empty threat. Similarly, the last equilibrium over here, where he also threat that he would always go for boxing, doesn't matter where she goes, even when she goes to ballot, he doesn't care. That also not reliable, right? Why? Because if he goes to boxing, when she goes to ballot, then he earns 0. But if he follows her, then he earns 1, right? So that is why it's also empty threat. So this one and this one. And only the strategies that following her is reliable in this case, and this is the rational Nash equilibrium in this case. So, alright, we have seen how first we define the Nash equilibria and then rule out some irrational ones to find out the most rational one. Next part, we will see another approach which can be faster to do that. Subgame perfect equilibrium is a concept can help us to overcome the shortcomings of the multiple Nash equilibria situation where we had on the board in which some may not be rational. What it does is it will rules out some empty threads, those threads that doesn't make sense at all. For example, the husband said he would anyway go to boxing even though the wife would go to ballet. Yeah. So when the equilibrium includes these contingencies, even though it's not occurred because the wife, for example, decided to go to boxing anyway, so that threat doesn't really happen. However, in general, it doesn't make sense. Yeah. So subgame perfect equilibrium is the thing to help us to rule out this situation. But first, we need some definition. A subgame, what is that? Is it just simply the part of the extensive form starting with a decision node and everything to the right-hand side of that decision node? Let's fly a little bit ahead to see. So this is the simultaneous game we had before now with the dotted circle. Now we have three decision nodes, right? 1, 2, 3. So this game has three subgames because a subgame is counted as a decision node and everything to the right of it. So to the right of the first decision node is the whole game, right? But to the right of this smaller decision node where the husband got to move is also a subgame, but like a smaller basic one. Okay, let's go back. We have something still on the slide. So a proper subgame. Unlike the subgame, the proper subgame starts with a decision node not connected to any other information set. What does that mean? It means, if you remember, with this simultaneous game, the decision of the husband actually comes from the same information set with the decision of the wife, right? Because all the information they have up to the point they got to move on, they decide their strategies the same. No one knows better than the other. No? So that's why this simultaneous games is only one proper subgame, which is the large game, the whole game itself, because there's only one information set where all the three decision nodes starting from. Okay. On the other hand, if we look at the sequential game now, the situation is completely different. You don't have the dotted circle anymore. That's the difference, of course, but that's not what I wanted to say. So now you see the wife move first. So she has her information set which served her decision, right? And then once she moved already, the husband got to move. And in this case, these decision nodes they all have different information set compared to the one that the wife used in the beginning. Why? Because that was also includes the decision of the wife inside. So the two have their different information set. And if you compare these two subgames, the proper subgame. The second and the third one, for example, the information sets of these two decisions also different. Why? Because the scenario is different. What the wife decided in these two situations is different. So the information set they have is also different. And that's why they consider also two proper subgames. So in conclusion, this sequential games has three proper subgames, right? The big game itself, the small one started with the first decision note of the husband and another decision note of him in case the wife moved differently. Yeah. Now we can talk about subgame perfect equilibrium, the rational equilibrium. Yeah. So the definition of it is a strategy profile that constitutes a Nash equilibrium for every proper subgame. Go back to the chart to see what that means. It means that the equilibrium, in order for it to be a subgame perfect equilibrium, it's not only that it has to be a Nash equilibrium for the whole game, like we did before with the underlining procedure, but it also has to be the equilibrium, the Nash equilibrium for these two subgames, like this two one. It must make sense for these two decision nodes already. Yeah. So for example, I talk more about it later, but focusing on the second subgame. If the wife goes for ballet already and the husband goes for boxing, it doesn't make sense. Why? Because he would earn payoff 1 if he goes to ballet, but 0 when he goes to boxing. So any possible strategy involving playing boxing when the wife playing ballet is not rational, right? So any Nash equilibria that involves that choice will not be rational or reliable. And we could rule out those equilibria. Okay. So by this definition, a subgame perfect equilibrium is always a Nash equilibrium of the big game, right? Because it has to be the Nash equilibrium for every subgame, every proper subgame, including the big one, the overall one, because it itself is a proper subgame. Yeah? And like I just said, that will rule out any empty thread in a sequential game. Like, for example, the thread that the husband would go for boxing when the wife goes for ballet. So what we have done up to now is we first use underlining procedure to identify all the Nash equilibria, right? And then we think more about those irrational choices and we roll out some of them. However, there's a shortcut to find the subgame perfect equilibrium. The rational equilibrium is called the backward induction. How does it work? So we, instead of going to the left, we go from the right. So we start with the smallest subgame, the farthest decision node to the right, and then we goes back to the left. So that means first for every small unit of the subgame, the proper subgame, on the right hand side, we compute the Nash equilibria for the furthest games, subgames at the decision node of the husband. And the next step, we substitute his equilibrium strategy for the subgames themselves. And finally, we simplified the big game. So, and then see from the perspective of the wife what is the best to do. It's a little bit hard to imagine, but we could talk more on the next slide. Now, this is the extensive form of the sequential battles of the sexes again. Now, so what backward induction means is we focus on the smallest, the simplest subgame on the right-hand side first, which are in this case the decision nodes of the husband, right? And we identified the Nash equilibria for these subgames. And then we go backward to the left-hand side. So let's start with the second subgame. No, this is the third. Okay. The second subgames now involved only the decision of the husband because the wife moved already. She has nothing to do now, just wait for the decision of the husband, right? So we don't have to care about the payoff of her because now it totally depends on his movement. Nah? So if he goes to ballet, then he gets payoff 1. If he goes to boxing, he gets payoff 0. So the equilibrium, the Nash equilibrium in this case is for him to go to ballet, right? So let's say Nash equilibrium for the subgame 2. Let's see about subgame 3. Now, once the wife chose boxing already, if he goes to ballet, he got nothing. If he goes to boxing, then he gets 2, right? So he would choose to go to boxing then. So this is the Nash equilibrium of the third subgame. Okay, we're done with the first step. The second step, we replace this big subgame by the Nash equilibrium of that subgame itself. So here, contingent on the wife playing ballet, the husband would play ballet, right? And the payoff is again 2 for wife, 1 for husband. And then with the third subgame, the number 3, contingent on the wife playing boxing, he would go for boxing because this is the Nash equilibrium of that subgame now, and this is the payoff that they have now. Okay, so based on this, it turned to the wife decision. Now she would think that, okay, that's clear. If I go to ballet, that's what he chose. If I go to boxing, that's what he chose. And it becomes a simple decision for her, right? And that is actually what's written by the only Nash equilibrium left after we ruled out two irrational ones from the underlying procedure before. And what would the wife choose now? She would go to ballet, right? Because she has more payoff now rather than boxing. So it's down to the subgame perfect equilibrium in which the wife goes for ballet and the husband will play ballet, ballet, which is here, and boxing, boxing, which is here.